We have previously discussed the ideas of an even function and an odd function, and we want to talk about it a little bit more here and discuss the even and odd identities, or also called the negative angle identities. A function is even if evaluating the function at a negative value and at a positive value gives you exactly the same result. So for example, if we were evaluating cosine of negative pi over 6, if it's an even function, this should be equal to cosine of positive pi over 6. So positive pi over 6, that cosine value would be right here. That would be positive square root of 3 over 2. And negative pi over 6 would actually be coterminal with 11 pi over 6, and that x value is also square root of 3 over 2. So when we talk about our even identities, we're talking about cosine and secant. These are both even functions, and cosine of a negative angle will be equal to cosine of a positive angle. Secant of a negative angle will be equal to secant of the same positive angle. The odd functions would be sine, tangent, cosecant, and cotangent. And when we're talking about an odd function, we mean that if we evaluate the function at a negative angle and at a positive angle, their outputs would have exactly opposite signs. So for example, if we evaluate sine of negative pi over 6, and of course that would be right here, we just talked about that, that would be negative 1/2. This would be equivalent to minus, or the opposite sign there, of sine of positive pi over 6. So when we look up here at positive pi over 6, that's a positive 1/2. So their outputs have opposite signs, and we can make them equivalent by putting a negative in front of that positive angle. So negative 1/2 equals to negative 1/2. So we're talking about odd functions. We're basically saying that the negative on the inside is equivalent to having a negative on the outside. So for example, if we knew that tangent theta was equal to 2.6, and we were asked to find tangent of negative theta, using our definition of an odd function, tangent of negative theta would be equal to minus tangent of positive theta. So the negative on the inside can come to the outside. Well, we already know that negative tangent of theta, well, we already know tangent theta is equal to 2.6. So let's substitute tangent theta with 2.6. So now we would say that tangent of negative theta would be equal to negative 2.6. So the outputs would be the same numbers but opposite signs if the angles on the inside are same values but opposite signs. Cosine is an even function, so cosine of negative 2 pi over 3 would be equal to exactly the same thing as cosine of positive 2.3. So if we know that cosine of positive 2.3 is a negative 1/2, then we know that cosine of negative 2 pi over 3 would also be equal to negative 1/2. Sine of negative 2 pi over 3, since sine is an odd function, this would be equivalent to negative, or the opposite sign of sine of the positive angle. So if I put positive 2 pi over 3 on the inside, sine of 2 pi over 3 would be equal to square root of 3 divided by 2, and we'll bring our negative out. So sine of negative 2 pi over 3 would be equal to negative square root of 3 divided by 2.